let's go to page 397. This is lesson 6.6. This lesson is to use proportionality theorem. Okay. So the mid-segment theorem, which you learn on page 295, is a special case on a triangle proportionality theorem and its converse. So again, we covered this earlier. Okay. So theorem 6.4, triangle proportionality theorem. So if a line parallel to one side of the triangle, so if a line parallel to the side of a triangle intersect the other two sides, then it divides two sides proportional. Okay, so what happens? What they're saying is that when you have parallel line, it will form the proportion. Remember, I have this example earlier. It looks like a ladder, right? Remember that. So whenever you have parallel lines, okay, whenever you have parallel lines, then you can write a proportional equation any way you want, right? Remember, we did something like this one, right? So you got A, B, C, and let's call this X, Y, Z, right? Okay, so if you have parallel lines, then you can write your proportional, whether it's triangle or not, because if you make this long enough, it becomes a triangle, right? So it does not have to be a triangle. As long as you have parallel lines, you can write your proportional any way you want, okay? So again, you can have A over B equal to X over Y, right? Just match up exactly. Okay, you can have A over C equal to X over Z, okay? And you can even add things. Okay, you can have A plus B over B plus C equal to, okay, A plus B equal to X plus Y and over Y plus Z. So this kind of quick review from before. So when you have parallel line, everything is proportional, and you can write any way you want as long as you match things correctly. Okay. Okay. Now, theorem 6.5 is a converse. Okay. So what converse is that if these things are proportional, then the lines are parallel. Okay. So over here, if the lines are parallel, then you can write proportional. All the sides lengths are proportional. Over here, if the side lengths are proportional, then the lines are parallel. Okay. Okay. So now let's go ahead and find the length of each side. Okay. So let's go to. Okay. So over here. So you see the marking, so it tells you that they are parallel, so that's kind of nice, okay? And they give you the number, so what is the length of RQ? So what is this X over here, okay? Okay, so you can write proportional, right? So you got X over 9, so whatever you see is whatever you put down here, okay? That would be easier thing to do, okay? So you don't have to kind of try to, make things complicated. So you got X over 9, see that? X over 9 equal to 4 over 6, okay? And that would be your equation. So that's the easy way to write your equation, by just write down whatever you see. So X over 9 equal to 4 over 6. And to solve for X, you multiply both sides by 9, okay, to cancel out, right? You don't have to cross multiply, because when you do the cross multiplication, you have to end up divide, you have to do one extra step. And X will equal to 6, right? And that's it, okay? And so that's your answer out here, okay? Okay, now let's go to the next one. Okay, reasoning. So theorem 6.4 and 6.5 also tells you that if the lines are not parallel, then proportionals are not true, and vice versa. So again, if they are not proportional, then the lines are not parallel. And if the lines are not parallel, then they are not proportional. Okay, so that's kind of the opposite of that. Okay, so example 2. Solve real world problem. Okay, shoe rack. On the shoe rack shown, so AB. So what you want to do, you can draw your choice. So AB equal to 33. Okay, so that's good. So you have this. So you got C, B, A, D, E. Okay. Okay, so let's see. So AB equal to 33. Now I want to write it on the inside, because the number on the outside I want to use it for the whole thing. So that will be less confusing. Okay? Because if you write it out here, sometimes it's kind of hard to tell if this is for here or for the whole thing. So if I write in here, I know it is for here only. Okay? And BC equal to 27. So right away you know that this is 60. Okay? Again, the number on the outside is for the whole length, and the number on the inside just for the partial length. And CD equal to 44. and DE equal to 25. Okay? Explain why the shelf is not parallel to the floor. So here's the shelf. Okay? Okay, well, you can kind of just do the ratio, right? So you got 27 over 33, and this is 44 over 25. Okay, and you can see there, you cannot even reduce, so they're not equal, right? So they're not equal, okay? Therefore, it's not parallel, okay? So what you have is BC over, okay, so BC over AB is not equal to CD over DE, okay? So therefore, it's not parallel, okay? Okay. So this is what we covered earlier. So theorem 6.6, okay? If three parallel lines intersect two transversal, then they divide transversal proportionally. So what it's saying is that when you have parallel lines, so everything will be proportional. So you have parallel lines cutting through the transversal. They kind of turn the picture the other way. I like to do it this way because this is easier to see and easier to work with, okay? So again, that's what it's saying. So when you have parallel lines cut through the two transversals, everything is proportional, okay? Now, there's something new is the theorem 6.7, okay? The angle bisector theorem, okay? So I'm going to turn the picture the other way. I'm going to do it this way, okay? So this is angle C, B, D, A, and this is angle congruent, okay? Okay, so what it's saying is that when you have angle bisector, I want you to turn triangle this way, and there's a reason for that. So that this side is, I'm going to call this side A, B, C, D, okay? When you turn the triangle this way, when you have angle bisector, and you turn it this way, so that they are next to each other, whatever you see, that's your proportion equation. So you just make this equal to, that's your equation, see that? So you got A over B equal to D over C, okay? So if you turn this way, whatever you see, that is your proportion, okay? So remember to turn your triangle this way so that, easier to see, easier to write your proportionality, okay? So that's what this is saying. So this is kind of harder to, when you turn triangle sideways, sometimes kind of hard to see, okay? But basically, that's what it is, okay? So this is a very important theorem. It's very useful, so remember that, okay? Okay, let's go to example. Okay, so city travel. Okay, so in the diagram, angle 1, 2, 3 are all congruent. Well, if they're all congruent, that means all these lines are parallel because if the corresponding angles are congruent, then the lines are parallel, right? So from the theorem before, right? So you can angle 1, angle 2, angle 3 are all congruent. So all these are corresponding angles. So if all the corresponding angles are congruent, all lines are parallel. So that's what we can conclude from these, okay? Because of that, so all these are parallel. Okay, but anyway, so GF, so this is 120, and this is 300, this is 150. From the distance HF, from this distance. Okay, actually this is fairly easy because you can see over here, everything is proportional, right? So notice that this is twice as that. I mean, you can go and write all the equation you want and solve, right? You can do all these, do all this and solve, okay? But it's easy if you just look, okay? This is twice as that, right? This is twice as that, so this would be twice as that, so this will be 240, okay? And therefore, HF would be 360, and that's your answer, see that? Okay? So again, if you know your theorem, you can actually, a lot of problems are super easy. You can just do it and look and answer is obvious, okay? Or you can just do all this, you can write the proportionality and you substitute the numbers and you work it out, okay? So you can, again, do whichever way is easier for you, okay? Okay. Now let's go to example 7. Okay, so right away you see this over here. Two angles are congruent, okay? So that's your angle bisector theorem, right? So you want to find the length of RS. looking for the x, okay? Okay, so what you need to do is, again, let's go and draw the triangle. I'm going to turn this the sideways, okay? Okay, so that's going to turn the picture this way. Again, it does not be proportional, okay? Does not be same picture. So this is angle P. So again, I'm turning the picture sideways. So this is 7, 13. This is X, and this is 15. This is Q, and this is R and S. Okay? So this is the picture that you have. Okay? So what I'm going to do is, actually, you know, this 13 is outside. This is the whole length I'm doing outside. Okay. So if this is 15, this is X, right? So to get this would be 15 minus X, right? So this is the whole thing. So 15 minus X will give you that. So you need to have this side over here. Okay? Then from here, you can write your equation, right? Remember, whatever you see is what you get, right? So you got 13 over X, right? 13 over X equal to 7 over 15 minus X. Okay? So from here, okay, so from here, you're just going to cross multiply. Okay, so cross multiply, you got 7x equal to, get your calculator. So you can multiply out, so you got 13 times 15. So you got 195 minus 13x. Okay? And then from here, so from here, you're going to just use your algebra plus 13x, plus 13x. So you got 20x equal to 195, okay? And you divide by 20, so x equal to 195 divided by 20 equal to 9.75, and that's your answer, okay? So again, it's a lot easier if you turn your triangle this way so that whatever you see, okay, is your equation. So 13 over x equal to 7 over 15 minus x, okay? And also, one more trick you need to do is that whenever they give you the whole length, right, you need to figure out the partial length. Vice versa. If they give you the partial length, try to find the total length. And from there, and if you don't have the length, just assign a variable. Like if you don't know the length, you don't have a variable, right? And you can use that to find this, okay? So again, if you have the numbers, write the numbers. If you don't have numbers, write the variable. And from there, you can go and solve.